Ready whenever.
Welcome back to problem 2. And before I get started, I wanted to answer one of my fan mail questions that has already been sent in only 23 minutes ago. And the first question is, your first video was so great that I wondered, how many takes did it take you? Well, Mr. Bishop and I are so great that first take we nailed it. So thanks, keep the fan mail coming in, and we will definitely answer those as they come in. All right, back on to the use of Snell's Law and worrying about these refraction of light in different mediums. All right, so today's question is problem 2, emerging angle. All right, so here's a picture of the situation here. We have light coming in, and there is a certain angle that it is coming in at, and we are exiting at a certain angle here. Now, if you want, I want to play specifics, make some specific notes on some things here. This dashed line is the normal line. If you recall, normal means perpendicular. Perpendicular to what? The surface. There's the water surface, nice green, like many of the ponds around where I live. So green is the watercolor for us. I'm out of blue, actually. So now the perpendicular line is this brown line. Now, it's always, these angles in Snell's Law are always with respect to the vertical to the surface. Okay, so if you got perpendicular, there's the vertical, there's the surface, it's here, and over here it's here. Now you got to be careful, they may ask for this angle, but Snell's Law uses those. So what is Snell's Law? N1 sine theta 1 equals N2 sine theta 2. Okay, N1 sine theta 1 equals N2 sine theta 2. I'm going to let this side be my water, and this side is my air. Okay, so there we have the two sides. So when we take, when we look at this, it doesn't appear like we have too much of the information here. But recall that these two n values can be found, they're common substances, so they can be found on our sheet at the beginning of the CAPA folder set. I have a file in there that gives these. So when you look those up, the n of the water is 1.33, and we'll call this sine theta of the water, and air 1.00293 sine theta air. You might say, Mr. Intershot, it's so close to 1, could we get away with using 1? Yeah, you can. So if you wish to use 1 in this case, you'll be okay. All right, so now we've come to a problem, one equation with two unknowns. So we must go out and find another one. Many of you are thinking, oh yes, systems of equations. It's not going into that right now, so later. We'll get into a system of equations later, so I'm sorry to disappoint you in that regard. But what we do know is we have this distance here, the depth to where the flashlight's at, and the horizontal distance that the flashlight is from the exit point in from the water. So look, if you make this nice triangle, I've already made it up nice right over here. We have this triangle and we have this theta here. Well, we can use our basic trig, tangent, opposite over adjacent, and when we solve, make sure your calculator is in degrees, and we can solve for an angle of 31. Although if you wish radians, you may use radians. Do what you love. So 31 degrees. So now that is over, that's here. We just found this to be 31. But look, two parallel lines cut by a transversal geometry. Yes. So 31 degrees, this is alternate interior angles. Alternate interior angles are congruent when a transversal cuts parallel lines. So there we go. So theta W is 31 degrees. So now we can fill in again, and we can solve, 31, and all right. So now we can solve this. Take this and divide this over here, and we'll do this real quickly. Times sine 31. All right. Oops. Oops. Oopsie. I forgot my sign. Sine theta air. So now, we take this, I get 43.35 degrees. Okay, now the question is, this is what I get, but my answer, you can clearly see in the green box, is 46.6. That's not right. Where did we go wrong? The problem asks for the ray emerging with the water surface. If we look over here, you see the emerging ray makes with the water's surface. What did we find? We found this. This is the angle they want. So if this one is 43.35 degrees, what is this? Well, that's a right angle, so it's the complement of that. So 90 minus this, and we get 46.65 degrees. And there we have it.